So today I'm going to study CPython's parse tree generator. And maybe if I have time, I'm going to study a C++ project that implements Barnes hut. But before I do that, I'm gonna show my notes from the books that I'm reading. And yeah.
The Brain FM. We mix neuroscience and music to guide your brain into peak mental states. This is a focus track, clinically proven.
Now, like I've read a bunch of books already, but the next books are gonna.
Compared to
Let
normal
me wait for
focus,
the music or the.
works best with headphones.
Uh, These books here are gonna take a lot of time, so I wanna finish them first before start streaming more often again. So each one of them I think is gonna take around 8 hours or more. Like this professional and the OpenGL one and the introduction to algorithms is the biggest one. And that's at 3x speed. I'm probably gonna go slower at some points. This one I already seen in the beginning that is kind of hard, so like I'm gonna have to take it a lot slower. And then these other ones I just found as well, so I want to finish all of them. Uh, so I'm not really sure if I'm gonna be able to do that until the end of this week, but I'm gonna try to. So let's see what I wrote down here. I think I'm only gonna be able to really understand how it works once I start building the projects, but I think that's like there's a lot of parts that I'm already getting tired of reading the same stuff over and over again, so I'm just skipping the books, which is a good sign, I think. But the parts that are more confusing, the most confusing so far are templates and understanding typing and operator overload and default arguments and stuff like that with classes and inheritance. That's the stuff that I'm the most confused about, and most of the books don't talk a lot about smart pointers, unique and shared pointers as well. That's another part that's going to be very hard. So let's see. Type of value depends on the way it's used. Structs are just, I like classes but have everything public by default. The preprocessor macros is a table of names, works as linked lists that resolve the names from the C programming language. Okay. Templates can't be declared inside functions. The star operator has lower precedence than plus plus operator and has higher precedence than the plus operator. Default arguments sometimes provide a shorthand form of function overloading. Yeah, so I'm not 100% sure, but based on the books, like I think that's what they mean is that a default argument is just a function overloading. So you're just function overloading is when you create multiple functions with the same name but with different types. So like the function, and it's very similar, I think, templates and function overloading because it's trying to achieve the same thing, but it does it in a different way, I think. So like a template, I think, is just a more effective way for function overloading, as far as I understand now. So function overloading just means you can create the same name of the function with different types, and then you can use like with several different ways. And template is just a way to create a generic type. So a class is just a type. So you have the built-in types, which is boolean, integer, float, stuff like that, string. String is a pointer to an array, but have the built-in types, and then a class allows you to create your own types. That's pretty much the point of it. And then using templates allows you to create a placeholder so that you can put a customized, specify a customized type on the function. But it gets very confusing when you have inheritance, and because the other thing about inheritance is that you can use something that is called virtual. A virtual function is just a function that is the same in Python, which is abstract method in Python, which is just a function that, so you can create a class that serves like as a template for other classes. I forgot the name, interface, the name that they say a lot. So you create one class that is going to be an interface, which is kind of like a placeholder where you put a bunch of virtual functions. And then based on those virtual functions, it's going to create like the specification of which the classes that inherit from that class are going to have to implement the virtual functions. But then it gets kind of confusing with the types. And also it's very confusing because of the pointers. So there's a bunch of situations that I kind of went very fast over it because there's so many books to read, but like it was very confusing to understand like when you instantiate a class how it's gonna work on with the pointers, like what is each thing referencing to with all these other nuances. So I think I'm just gonna be able to grasp that. Probably the videos are gonna help a lot more with that part, and then like also trying to build stuff and looking at real code from projects. I think it's gonna help. If you use type def to declare pointers, then you can declare multiple pointers on the same line. So this is another thing that all the books talk about. That if you do this declaration here, then only the first one's gonna be a pointer. It's usually like this, and the other one's gonna be an integer, and then they all say you shouldn't do that. So if you use type def, then it allows you to declare both of them at the same line. But I'm not really sure why you would do that because it's kind of confusing. I think it's always better probably to just declare in two different lines, or to do this. Yeah, from thinking in C++, object-oriented programming can be summed up in a single phrase, sending messages to objects. Units can have constructor and destructor, but can't be used as base classes. So in C, the constructor and destructor is just the name of the class, and it is the function that is going to initialize the class. So in Python is init, and in JavaScript is constructor as well. So it's just the name. So if you have a class called cat, let's say, then you just do cat, and then the function that's going to be the constructor, and then destructor is just with this thing here. And then you have to declare them inside of the class, and then you define them somewhere else, either on the header file or on the C++ file. So you do like this to access the thing, and then I think you put like this, the definition. I don't remember exactly like very well. That's how you do it. And there's also, I think I wrote down some stuff here, but they recommend you to, like the reason why you have 3 different types or 4 different types, I think, of specifiers, like you have public, private, protected, and you have friend functions, is because you don't want to expose, there's some situations where you don't want to expose the data to the outside world, let's say. Let's say, for example, you're creating an API, then you don't necessarily want the people to use the API to know the methods in some cases. So that's why classes are private by default. But then the downside of that is that whenever something is private on the class, if you want to access the thing, then you can't access from the outside, obviously. So the way people get around that is by creating getters and setters functions. Then they make the functions public, and then they make the attributes private. So that way people can't access the attributes outside, but then they can access through the functions. But it's kind of something kind of confusing as well, because like, and this is the issue with the books, is that they it's not like the problem of the book, let's say, because it's very hard to encode like the whole project in the book format. So none of them I found that is very good to look at the whole project and understand like on what kind of situation it would be better to set stuff as private and what kind of situation is not. And then there's some stuff that they say that whenever you have to declare things on header files, it's kind of bad because of this reason, because you have to make them public. So if you don't want to do that, there's something called inline functions. That one is still very confusing to me. I don't understand really well how it works. And then the friend function is also very confusing. It's just whenever you use a friend keyword, it just allows you to use that function on another class. So even if it's private, I think, I'm not 100% sure. And the protected is whenever a class that inherits from the other class can use the function. So it's kind of like a private, but with a little bit more open. So because the other classes can use. But all this stuff is very confusing, not gonna lie. So probably gonna have to review. Then this stuff is because sometimes in some situations, if you don't put parentheses on macros, depending on which kind of expression you put pass to the macro, it's gonna change the precedence because of the operators. So it might fuck up the function you put out there on the macro. So they recommend you put parentheses on everything. Reference is like a constant pointer that is automatically dereferenced. Yeah, so in C++ it's slightly different, this symbol from the star. So this is the reference and the other one is the pointer. And in C, I think they're pretty much the same, but C++ they are slightly different. Reference cannot be changed to refer to another object, pointers can. This one's very confusing as well, but now I think I get it. Whenever the const is in front, that means that the variable that the pointer is pointing to is constant. But if the constant comes later, then it means that the pointer is constant. So here the pointer is constant and the variable not necessarily. So that means you can't change the pointer, but you can change the variable that the pointer is pointing to. And here it means that the variable is constant. So you can change the pointer, but you can't change the variable. And then here is both of them are constant. And this one is the algorithms that are used on the standard library that require data to be sorted. These ones are usually sorted but not required. So the standard library is just like they took obviously the algorithms that people use most of the time, then they optimize them as much as they can, and then obviously it doesn't make all the books, or not all the books, but all the books that talk about algorithms always recommend to use the algorithms from the standard library instead of creating normal loops. So I think that's something that you should try to do, but obviously it's going to be hard in the beginning. Let's see. Oh yeah, and everything is a container. So like they call it a container, but it's just like it's just classes that are built in on the, I think it's standard library as well, that come with C++ that you should use. Some books talk about them. So string is one, and vector is another one. I think it's probably the ones that are most used. And then I think there are other data structures as well, like trees and heaps and queues and stuff like that. I have to study more of that data structures. So design patterns, relationship with compilers, AST is an instance of composite pattern. Flyweight shows how to share terminal symbols within the abstract syntax tree. So terminal symbols are the words of the language, let's say. The definition of the smallest symbol that represents something on the language. So I think a good way to think about it is just words. So for example, if is usually gonna be a terminal symbol, is a Lex token. And the non-terminal symbols are phrases. So when you put phrases together, and that's the purpose of the abstract syntax tree. So this is another thing. I think I'm gonna talk about that once I finish talking about this stuff here. But there is, I understood now I think I understood the difference between regex and grammar. So yeah, iterator, the interpreter can use an iterator to traverse the structure to maintain the behavior in each node. Prefer declaring private functionality as static functions. Oh, this is another thing that I realized on the project that I was working on. I'm not really sure if that, I think it's probably not the reason why I had the bug, but it's something that's, and this is I'm not 100% sure because they talk about static variables and they can be dangerous because of multi-threading. And one of the books talked about that, but from the example in the book, it seems like the way that they recommend you to do is different than the way that I was doing there. But I'm not 100% sure if it works because I haven't tested yet, and I don't think that was the problem with the thing, but it's probably a better way to do it. So the way that I was doing before is declaring variables here, like as global variables. So this is another thing. Whenever you want the global variable to be accessed on other files, you have to use this external keyword. which stands for external. No, it doesn't stand for, but it is supposed to like kind of remind you external linking. So extern is just a global variable that whenever you put the keyword, it allows other files to access the variable. Because the first process of the compilation is just turning everything into an object file, and then the second part is linking everything together. So the different files might not be aware of the other variables, so you have to use this keyword as far as I understand now. But I was doing more, I think, just with an int for these variables here, because I wanted to keep track of the IDs for each node, and each ID has to be unique, and I increased by 1 each time. So I was declaring here, and I was increasing, or making it equal here, and then increasing. But then on one of the books, they explained that the static keyword is used to only make the compiler create the value once during the entire iteration of the program. But the difference between the static and the global and external variables is that the static is encapsulated by the scope of the function. So that's the main difference between them. So from the example that they give, I think that's the way I'm supposed to do it. So if you declare with static here, then what's going to happen is the next, like, let's say I call this function 2 different times outside of here. Then the second time is going to be, the current node is going to be 1 and not going to be 0, because it's going to increase here, and then because this is static, it only initializes the variable once. So I believe that this is the correct way to do it now, but I'm not 100% sure yet. I have to test, and I think that wasn't the problem. But I'm not really sure if I'm going to continue to try to debug this, but it's going to depend on how hard, because I want to start working on the other stuff, like creating the graph and parsing the code, or understanding more how compilers work. The biggest thing that is on my mind now, and I'm trying to clarify, is the difference, the main difference between data structures and algorithms. Like, what makes something be a data structure and what makes something be an algorithm. And it's very hard to understand, because I was thinking about, like, because everything is going to be compiled down to assembly, and then the assembly is going to use an assembler, which is a program to convert the assembly into machine code. So, like, and this is the problem, because obviously on a conceptual level, if you say like something is a data structure, it makes sense. But the issue is that either data structure or algorithm is always going to be boiled down to assembly eventually. So I think one way to think about the distinction is that assembly or data structure is something that changes during the execution of the program. But like, what does that even mean? Because like, it's all keywords at the end of the day, and it's going to be a deterministic or non-deterministic final automata that generates the code on the thing. And then, like, there's 2 different distinctions. One is for a program that has an API or does requests, for example. So in the code of the request, what's going to happen is that the operational system is going to receive a signal, and then based on the signal, it's going to call a bunch of other code to make requests, which are going to interfere with the Ethernet or the modem. And the modem has a bunch of other processes that have a bus and communicate with each other. And then it kind of works like as a loop, I think. So, and then there's obviously multi-threading, because then, like, once you set up the signal, it's going to send another signal, and then there's going to be some logic that is going to continue or queue processes based on whether or not the signal was responded, let's say. And then there's a bunch of things to deal with, the access to the lock of the computer and the threads and stuff like that. So, but this is the thing that because at the end of the day, it's all going to be code, and it's all going to be machine code on the hardware. So, like, if you think about it from the perspective of the hardware, and you forget everything else, it's just a bunch of binary impulses changing over time. So what I want to understand is, on the hardware, what is the distinction between data structures and algorithms? And then, like, because I was thinking about, based on that, let's say you make an API request, and then you receive some data, and then based on that data, it changes the logic of the code. So one way to think about it is that the code itself is more static, the algorithm, because it's just one conversion that you do. But then, like, what exactly happens during this part? So I think I have to study more like the back end of the compilers to understand this, because everything should be translated into machine code in the compilation process. So like should be all binary impulses by the time the data is changing on the program. So what determines how do you draw the line between like what is considered to be a data structure and what is considered to be an algorithm? Because at the end of the day, it's going to be the same thing. Like, so I think the main difference is and this is what I was thinking. It's like data structure is just the symbol table, I think, because variables are placeholders, which made me think about, which makes a lot of sense, the mathematical equations. So everything is a mathematical equation, I think, at the end of the day. So it's very, yeah, I don't know why I didn't realize that. I think I did realize, but it's kind of confused, like, because it's not necessarily the same. There's the additional logic as well. It's not pure, it is mathematics, but there's logic involved as well. So I think that's what makes it harder. But if you think about it, it's just like a function in mathematics. We have the variables, which are the stuff that changes, and then we have the constants, which remain constant, obviously. And then you have the function, which is the relationship between the variables. And I think that's what programming boils down to, is just mathematical equations. And the interface of the hardware is going to be the symbolic representation of how the impulses are translated based on the mathematical equations through the informational system that is computing. Never call virtual functions from your constructor or destructor. Not really sure why. I don't remember, but declaring privates other than exposing them. Okay. Why declaring functions as override for virtual until you have a valid and compelling reason need to do so. So this is one of the things I think on the last book that I was reading, which is Thinking in C++. He recommends that you always prefer composition instead of inheritance, and I think a lot of people recommend that as well. And composition is just a fancy way to say that you're going to use one class inside of the other class. So inheritance is when you copy paste all the code from the base class into the child class, and composition, you're just creating an instance of the class inside of the other one. So you're not copying and pasting the class. That's the biggest difference. So based on what he recommends, you should prefer inheritance whenever you want to create an interface. An interface is going to be a class that has virtual functions which serves as like a template for the other classes. So you're kind of like creating a mold. I'm not really sure how to say this, but like a standard from which all the classes from that derive from that class are going to follow. So whenever you need that, it's better to use inheritance, because then you can create the interface, and you can kind of have a standard between classes. But if you're not doing that, then it's always better to do composition, because then you don't couple things together. And I think this is related to it's always going to be the balance of the variance of the data. I think that the variance of the data determines the structure of the functions, because just like in physics. So like the variables determine the function, because the function is just a placeholder for a variance of the variables. Try to keep details private. Downsides of templates APIs that it forces to expose details on headers. Yeah, so I think that's it. Let me talk about I'm talking about all this stuff because I want to organize my thoughts. This is the first time that I'm going to look into this program here. And this is the peg parser in Python. So yeah, let me talk about rather than explain how I'm thinking about this now, and then I'm going to look at the code. I think I'm going to show the notes that I have. I'm reading this book now. And this one, I'm going back and forth between this one and the other ones because they're all going to take a bunch of time. So I think in order to not get bored with any of them, I'm going to go back and forth, but it's probably going to take me a lot of time to finish them. But I'm also writing a bunch of notes. So let me say, I'm going to go over the notes, but I'm going to talk about the regex first. So as far as I understand now, regex is just a way to structure sets. You set logic on data, which is the inputs that you get, which is the string. So any program is going to be a string, and then based on that string, you're going to create other strings. And then the bottom layer is the assembly, and the assembly is converted into machine code based on something called instruction set architecture, which is the standard that people create. I think it's on the operational system actually, because the operational system is the layer above the hardware. So the operational system communicates with the hardware and runs the programs, I think. But I'm not 100% sure, because I know that on one assembler is NAS, I think, the way that is SAS. So it's just a program that converts the assembly into machine code. So like, obviously it's all going to be the same at the end of the day, but I think the common denominator, lowest common denominator to all high-level languages is going to be assembly. And the assembly is going to be converted into machine code instructions based on combinatorial logic. So you're just hard coding the binary operations. So you have a truth table that represents the concept of what an impulse is going to be, which is used with EEPROM and hexacoder. So obviously, I always talk about this guy, and I think that's like his videos are the best, and that's where I learned this stuff. I'm probably gonna watch them again. I watched this series a bunch of times already, but it's very good, and it takes some time to understand. As far as I understand now, it's like around the EEPROMs, yeah, around here. So the way that he shows, at least, and I think it makes sense, is that you have like a LED display, like here, and then you have an EEPROM, which allows you to hard code combinatorial logic. So you're just like programming, you're just gonna program it one time, and then it's gonna have the impulse, and then based on those impulses, so it's gonna be just inputs and outputs. So based on the inputs, it has a truth table that translates that input into a symbolic representation of what the input is. So it's kind of like encoding data into symbols, but arbitrarily. So you decide that this combination of the truth table is going to mean that is the letter A, for example. And then on the hardware, you have the impulses, and then that's going to be, whenever you have a certain set of impulses, you're going to determine that this is A. And that's what the instruction set architecture is. It's just a convention to translate data, it's binary impulses, into a symbolic representation of them. So the first jump, it doesn't have any meaning. It does have a meaning on physics, but it's not a direct meaning. It's just an indirect meaning. And I think it's indirect because it encodes the geometrical structure of space-time, I think. So, for example, if you encode the impulses to create the display of a letter A, and into a truth table, I think that says something like it has a physical property because it's a certain amount of impulses that are creating that concept, but it's not direct because there isn't anything that says you should encode the letter A this way. So it's just an arbitrary representation, because you could theoretically say that any impulse you're going to consider as the letter A, it doesn't necessarily need to create the LED display of the A. So it's kind of like a, and I think that this is a reflection of the symbolic representation of the collective consciousness. So the language that people use to communicate with themselves is already this process of, is projecting the nature of consciousness of human beings into the computer by these standards in the first place. Then after this jump with the instruction set architecture, you have higher level languages, and all of them are going to be boiled down into assembly. So at the end of the day, I think that algorithms are data structures. It's all the same thing because the program doesn't understand what things are. So but going back to regex, the way that it works is that you always have an impulse, which is going to be a string, which is the input of the file, and then that input is going to be converted into the smallest representation that you can have on the language, which you decide, which is the grammar. But if for regex, and this is the downside of the book that I didn't like that much, is that they don't explain very well like the details. I think they don't go very in depth into the code. They just like it seems like they do some jumps, so it's kind of hard for me to understand. But like from the regex part, but as far as I understand, what they're doing is that they're just attaching the logic of a symbol, which is the regex symbol, to a collection, show a pattern of the string. So you can imagine that you create a program that receives the regex pattern, and then based on that pattern, you have control flow that dictates what is going to happen every time that a certain symbol is going to be found. So for example, on regex, you have the small d, which is going to represent digits. So you can say, so if you, let's say you have the function that receives the d, which is the regex pattern, you can say that this is going to be equivalent to this string of digits. And then when you're parsing the file, what you're going to do is just look for whenever the token that you're parsing is included on this set or not. So, and this is the reason why regex is just encoding set logic. And then the operations on regex are based on this principle, because you can have another pattern that's going to be like a word, I think. I don't remember which one is the word, but whatever, it's going to be like this. And then you can have a union, for example, which would be like connecting all of them. So pasting this stuff here on the right here. And that would be another regex pattern. So that's all that regex is doing, is just using set operations. This set logic to create patterns to find keywords. But the reason why regex can parse everything is because the limitation of this is that you can't build sentences with this, because although you can find the patterns, how are you gonna find what something means? So, and this is kind of hard to explain, I think. But like, if you have something like this, dogs love food, like regex is gonna be is gonna allow you to find the pattern of dogs and love and food on the string that you pass. But then, like, how are you gonna use set logic to derive the meaning of the sentence? How do you decide how you connect the tokens? So like one way to connect would be like this, for example, which in this case is valid. Or I can do it, which in this case would be weird. So in this situation, you say that the grammar is ambiguous because you can have two different phrases that have valid meaning. So there isn't anything that forces you to use one over the other. So grammars allow you to create the structure of the language because they allow you to create meaning out of the words, which are the tokens. So the tokens are the smallest representation. And it goes back to the thing that is kind of arbitrary because you decide what are going to be the rules and what are going to be the tokens. So when you think about it, is just that the language is the symbolic representation of the logic that creates computation. So in natural languages, I think they are ambiguous, but then it increases the difficulty in computing exponentially, because you can think about that if you have a bunch of different phrases and either one of them can mean something, like how do you determine when you're executing the program what exactly does the phrase mean? And this is the reason why I think that most programming languages, if not all, they can't be ambiguous. They have to, if you have a phrase, it has to be something. Like only one thing. And that's the difference between non-deterministic finite automata and deterministic finite automata. Non-deterministic finite automata is just a fancy word to describe this, because you can imagine that, like, if you're going to start with a string, and like let's say you start with this string, like the first process is going to be finding the tokens, which are part of the rules of the grammar, and then you're going to put them on, like, on a vector probably, and then based on that you're going to go over them again, and then you're going to build the abstract syntax tree from them, or the parse tree. So like the way you can go from one string or from tokens to build the tree is going to depend on which way you decide to go about putting the trees first, constructing the nodes. So one way could be that you create the dog as a parent of the food and love. And the other way would be like you have the love on top and so on and so forth. So if you have an ambiguous grammar, there's like several different ways that you can build the abstract syntax tree, and it becomes exponentially harder. But if you have a deterministic grammar, which is just one phrase for each thing, then whenever that phrase is not built, the compiler is going to throw an error, I think. So you only have one way to build the tree. And I think that all of them are going to be either recursive descent or all of them are going to be recursive descent, but some of them are going to start from the left and some of them are going to start from the right to recurse. And this part I don't understand very well yet, so I have to study more. But then once he builds the abstract syntax tree, he's going to traverse the tree later on to build the intermediate representation, which is going to be the assembly version of the code, which depending on what kind of language you're going to have different, because in this part there's a lot of optimization, I think. So in Python, I think that you have another language, which is just is kind of like a more generic assembly language that works for several different architectures. But on some other languages, probably you're gonna have like you're either gonna translate for one architecture or for the other. Like, but yeah, at that point you build the assembly language after you create the tree. And then once you create the assembly structures, then you just use the assembler to convert into machine code. But the backend parts I don't know very well yet. And during these parts, what you do as well is whenever you find the lexer, whenever you find the tokens on the thing, and you find a variable token, then you have to create a symbol table, because then you know that's how you're going to resolve the scope. So the symbol is the table is the place where symbol table is the place where you put all the variables, and that happens on the tokens, on the parsing, and on the intermediate thing, I think. And also then you have the control flow graph as well, which I don't remember really well how it works, but I think is in between the after the abstract syntax tree and before the intermediate representation. It's just a graph that represents the flow of the program. And then in Python, in CPython, the way that they do it, so over time people figure out that they can create software to automate the process of creating this logic. So instead of coding the functions yourself, you just create a parser generator, which is going to create the functions based on the grammar. So you have the rules of the grammar that are written in a Beckel's new form, which is the language for grammar. Then based on that, you create a program that takes that as an input and then creates the functions that are going to create the parse tree from that. And the parse tree is more complicated than the abstract syntax tree because it's more descriptive. So the abstract syntax tree is a simplification of the parse tree that encodes the information, or it simplifies the information. And that's kind of complicated, so I'm not gonna talk about it. But that's where I'm at right now. So let me read this stuff. And this is the stuff that I wanna study here. So this is supposed to be the program that is gonna take a grammar and is gonna create the functions, which I've seen some of them on CPython that are responsible for creating the parse tree or the abstract syntax tree. So what I want to do is understand how this works so I can translate the grammar into functions. That's what I'm going to try to do now. I'm going to study this a lot more probably, but I'm going to try to convert this code here into C++ probably to create something that allows me to, from a grammar, create a parse tree. And the main thing that I'm trying to clarify now is, like I said, the main distinction or fundamental distinctions between data structures and algorithms. And how does that work on the hardware level? So let me read this, then I'll start studying that thing. Parse generates, produce. Oh, this is another thing that I found out. So I think it's more, like, it's probably smarter to try to figure out like how all these tools work, so I don't have to do the whole work of building everything by myself, and then use those tools to create the visualizations from the language. Produce lexical analyzers from regular expression description of the tokens of a language. Produce collections of routines for working and processing parse tree and generating intermediate code. Produce a code generator from a collection of rules for translating each operation of the intermediate language into the machine language for a target machine. Data flow analysis engine facilitates the gathering of information about how values are transmitted from one part of a program to each other parts. Key parts of code optimization. And this is the different types of architectures you have. I think the most used one is done with this one, but the x86 architecture is the 6. And I think these are the stuff that I was talking about, the standards from which assembly is going to become machine code, I think. It's going to depend on what kind of architecture it is. Architectures that have been proposed, data flow machines, vector machines. Data flow analysis developed for compiler optimizations, YAC. So this generates a translator directly from a translation scheme. Cursor descent, use both to parse and to implement syntax-directed translators. So the way that I think it works on CPython is just a left recursive descent, and it is deterministic. So whenever you have a rule for the grammar, so that means you have a non-terminal, which is a string that is kind of like a phrase. You're gonna convert that into either terminals or terminals, and in some situations you're gonna have several different options. So Python always gets the leftmost one first. It tries that first, and then if it doesn't work, it goes to the other ones from the left to the right. And that's the name of the thing, peg parser, I think, or peg parser generator, something like that. Regular expressions gets transformed first into non-deterministic finite automata, and then into the deterministic automata. So I think that all that programming languages are just these finite automatas. It's just transitions between states. And it's just different ways to encode data with symbolic representation, I think. So what I'm gonna try to do is just create this simulation on C++ using the Barney-Sutz thing to see if I can, based on an input, create the graph that is going to represent, based on the grammar, create a graph that represents the finite state or finite automata. Clean closure and positive closure, reject set logic, transitional diagrams. How does data change in runtime? This is the question that I want to investigate. Grammar is used to parse because regex can't build sentences and can't eliminate ambiguity. Top-down parsing is that first pre-order. Bottom-up is probably that first. So top-down is used with probably that first. It's not really search because they're building, but it's the same kind of thing. So I think top-down is using recursion, and bottom-up is probably using loops or a queue to build. And I think all of them use a stack. So the way that it works is that you, and also they talk about in the book using buffers to optimize. So you can use several different buffers, and then you put the limitations of the buffer. But pretty much how it works is that you're reading the file, and then as you read the characters, you put them on a stack. And then based on how many characters you have, you create the logic to... The one thing that is kind of confusing to me still is exactly how it works, because like from the lax tokens to the parsing, because I don't understand, like it makes sense to me the way that they are describing for the lax tokens, where you're just reading the file input and then you're creating the tokens based on the whatever character you see, and then you put them on a stack. Then based on the characters you have, you create a logic based on the rules that you define for each word, which is the lax tokens, and then you create a bunch of tokens which are probably going to be objects in most languages, depending on which language you're using to create a parser or to create a compiler. But it's not clear to me how. I think the only thing that makes sense to me is that it has to be on the same order that you loop over the tokens once you get all the lax tokens, and then you create the abstract syntax tree based on the same logic, but instead of reading the file, you're reading the tokens this time. So depending on which token you read and the rules of the grammar, you are going to build the parse tree and abstract syntax tree recursively. And then that's going to depend on which one you choose. If you choose top-down parsing, you're probably going to use recursion. And based on the rules of the grammar and the tokens you have, you're just going to like probably push them into an object or something as you traverse, as you go over the vector that has all of them, I think. And this one is probably using the queue. Shift reduce parsing. Oh, okay, so I'm gonna finally start looking at this code here. I'm probably not gonna stream for some time after today because I want to finish all the other thing, all the other books. I think I'm gonna try to follow the execution and see if I understand what's going on. I did, it's a little bit confusing and I kind of forgot, but there's two different files that have the rules of the grammar. I think the other file is on the CPython project, it's not there. But I'm pretty sure that that's the program that they use to create the parse tree, or to create the code that is going to create the parse tree. This is the grammar, and I think this is the tokens. One thing that I could try to do is just to run this and see if, how can I run. Let's see, man. And the problem is that maybe I have to read the documentation to see what kind of arguments are going to be passed to this. Args funk. Hmm. And in C++, the namespace is just a way you use to encapsulate variables. So if you want variables to have the same name as other variables, so let's say the standard library has a variable called, or a variable or function called dog, for example, and you don't wanna, you want to create a function with the same name or variable with the same name, but you don't want to conflict the two, then you create a namespace. And then to use, you use the two dots on C++. On the standard library, you just use like this, for example. Or you can just using std, and then it's just gonna convert, and then you don't have to type anymore. But then the problem is if you have a conflict, then it fucks up. So I need to remember how does it. I don't know if they have obviously they have a bunch of stuff that explains how everything works, but I don't know that if they have a part that explains how to run the generator. I'm gonna try to look on the documentation briefly, see if they have something. guide to the parser probably. 'Cause I don't think that they describe how the code is run. I want to understand what kind of arguments you're supposed to pass. Just see if I can understand how it works there on the function. I'll be right back. I just realized that there's probably it wouldn't be very efficient, I think, There's probably a way to use derivatives to find if a variable is on scope or not. Because and I think it's becoming more clear on my mind how everything works. But like scope is just a connection between functions. So whenever a variable is not on scope, it just means that the data that exists is not a cross section between the functions that are created. So you can think about a program as being a function, and different, like the program is a function that connects. It's like Lagrange interpolation, I think. So every software is doing Lagrange interpolation on multiple different functions. And then whenever a variable is out of scope, it means that you're trying to access data that doesn't exist on that function. And this is the part that is kind of confusing. Bang meta grammar that automatically generates a Python parser and is used for the parser generator itself. This means that there are no manually written parsers. Meta grammar is located at the parser generator that can directly produce C and Python AST objects. I think like it's kind of it's not very productive if I follow this path. I'm just gonna have to spend a bunch of time trying to figure out how the scripts that build everything work. It's kind of not, it doesn't make a lot of sense to me either. Like, how does it build the thing first? It has to be on these commands, I think, is the only thing that makes sense. So, like, whenever you build the executable, it just has some commands that are gonna run the grammar and it's gonna generate the code, and then, but once you run the executable, it is already gonna have the code for parsing or creating the tree. So the only way to see what kind of arguments is on reading it's reading that script and trying to parse the bad files, which are batch files, which run. You should use PowerShell commands, I think, to build everything with make, probably, or no, it uses MS Build, which is on Windows, which is a compiler, I think, for C that Microsoft created. So it uses the scripts use MS Build or define MS Build, and then they use that to compile everything, I think. So I think a good way to think about it is just that the grammar is a collection of regexes. But I'm not 100% sure about that, though. I guess one question is, like, how do you decide? Probably like stuff that the issue is that's it's gonna be hard to find, I think, explanations, because most of the resources are gonna talk about how it's done. But I'm thinking about, like, how do you decide what are the rules for the grammar? How do you know that they make sense? I think this part's still very confusing to me. Well, it has to do with Noam Chomsky, I think, the synthetic structures, and yeah, from what I remember roughly, the book talks about this, like, but very on the surface level. I don't remember really well. It doesn't have anything. I want to see if I can figure out without having to figure out all this other command line stuff, the part of the code that actually does actually creates the code for the parse tree. And I think I have to figure out the arguments. That's kind of the problem. Yeah, so I have to figure this out. So I want to understand what is obviously what the grammar is gonna be, because I don't know if it's gonna be the object file of the meta grammar here, and I have to understand this. Maybe I don't have to understand. Maybe I can just assume, like, yeah, I can look at the code for here and then derive what's the grammar might be because of that. Oh, it has here. This is gonna be grammar. Hmm. I guess if I search for this here. Hmm. Yeah, I need to understand what this is going to be, the rows and the meta. So I think what I want to achieve is be able to get from the file, create the grammar from the grammar file, create. The thing is that I'm not really sure if this creates the code or creates the. I think it creates the code, and then the code's gonna create the parse tree. What makes the most sense. Yeah, I think that's probably how it works. It wouldn't make sense to create a parse tree because you need to create a parse tree based on whatever input you have, which is gonna be the file that you parse. So the only thing that makes sense is that this is gonna create the code that is gonna parse, that is gonna create a parse tree. So I want to see if I can implement this. Just pass the grammar and then see the output. Which I think it's probably gonna take some time. I might have to go and explore the batch files to see what kind of commands is running. So to see how this is called. Maybe I can ask ChatGPT or search on a search engine. Well, what it makes the most sense for me is that it's gonna pass the file as an argument. But maybe just pass this flag variable and then based on the structure of the thing. So I have to understand the structure of the class that parses the arguments first. Then understand this thing. Let's see here. The main line is this one. That's the one that gets the objects. So maybe But it can't be the file because it's gonna be a function. And what does this return? In space source. I think this is the sys library from Python, and obviously, not obviously, but the sys handles the imports. And the inputs and outputs, standard inputs and outputs. So not, it has to be something. I imagine that this is getting is just getting the arguments that were passed. So on C and C++, the way that it works is that the main function, you're always gonna have a main function which is gonna run the software, and the main function has two arguments, and the standard is to call argc and argv, and the argc is the one that is an integer that represents how many arguments were passed, which is always at least 1 at the length, but the first one is going to be 0, I think, and that it represents what program is running, and the argv is going to be a list of pointers, and each pointer is going to be the command that was passed, because you can imagine that is a list of strings, but in C, a string is a pointer to an array, because strings are arrays. So if you have a list of strings, you have a list of pointers. So that's the argv. So imagine that this is the same here. So just getting the elements on the list that were passed when you call the program. But I don't understand how it has to be, because the problem is that the arguments are going to be strings, so it doesn't make a lot of sense. If it returns a string here, or a list of strings, and how is it possible that it's calling this thing here? So maybe if I just pass through ChatGPT. Args is known. I'll default to the system args. There's gonna be a list. And it doesn't help much. So I'm thinking that it's gonna be this one most of the time. I guess I can ask um, about this one as well to understand. But it has to be a list because I don't see any other. It just extends the list here, but it doesn't change. So I assume that what this is returning is a list. But it's actually destructuring, so each one is gonna be one value of the list. But no, no, this has to be a list, so it should be calling this on the list. With not really sure. It doesn't make sense to me. So maybe this just gets the element on the list that is called func. Don't know. I'm pretty sure it's the Python one. Let's do this. So maybe, but it wouldn't make sense to be the class. It's calling func from the class, but I guess I can look it up. So it looks like this one is the function that creates the parser. I want to understand what the... Like, if it takes too much time, then I'm just gonna go... Or obviously, I'm gonna spend a bunch of time trying to figure this out, but ideally, I would be able to do it without going over a bunch of other stuff. So I'm gonna try first. I wanna see if I can understand what the grammar thing is. If it is a class, an object. It's probably gonna be the class based on the other code. But I wanna understand what it is because I wanna see at what point does the file... I believe it's gonna be this one, but I'm not really sure. Based on the... It's kind of confusing there on the documentation, the way that they explain. But I believe that, as it says there, this is gonna be the one that is used to create the other one. Or... Yeah, I'm not really sure. Like, what is the relation between this one and the other one? So this is the one that... This one is used on this program, and the other grammar is used on the other one. But I'm not really sure what is the relationship between them. But I think that is gonna be this one that is used on this one, on this program. So I wanna see if I can understand at what point does it use the... And if I can't figure out with Python, with CPython, then what I'm gonna do is just study it directly. Because the name of the language is Becker's null form. It's kind of hard to say. And I know that is related to Noam Chomsky as well, synthetic structures. So what I'm gonna do, if I can figure out by look at the code, just look at the search for resources that explain how to create a program that translates the from this language here, which is the grammar, creates the code that is gonna create the parse tree. I can kind of... I believe I would be able to do it on my own with enough time, but then obviously it's gonna be inefficient, and there's higher risk that I'm gonna fuck something up. So, but the logic like seems... It's not that hard to think about it. Like, based on the thing, you're just gonna have like the options, and then you're gonna just branch the... You're gonna create a control flow inside of the function that is gonna determine based on the rules you have. How do you create the tree? And then you're gonna have some recursion. But obviously, like ideally, I'm gonna be able to figure out based on what they have here or somewhere else. And then based on this, like once I can go from the grammar to creating the code, then I'm gonna see if I can build the graph from this. And then I'm gonna study the other project. I'm probably gonna study soon the other one, like start studying the Barnstad one. And I'm probably gonna continue trying to make it happen with C++, because then it allows me to remove all the bullshit from the browser and just focus on the stuff that I actually care about, which is just creating the graph visualizations to understand how the grammar works. And I need to study more the backend as well. The main thing about that is I want to clarify is this relationship between data and algorithms. Like, how does it work? Because this is just one part of the thing. That's the problem. Like, I think I'm probably gonna have to create the graph that shows from the language to the assembly, and then highlight the path. I probably study assembly more and the instruction set architectures. So it's gonna call this and this. The name of the program. Usage message. Also, it inherits from these ones. Just prog and usage. Oh no, it's this description. And this is stuff that I was saying in the beginning. That in C++ is gonna be virtual functions. And it's kind of weird because it doesn't have abstract syntax class here. In Python, when you're creating the interface for other functions to use like the same logic for a virtual, you usually from the code that I sing, you inherit from the AABC class, abstract basic. No. I think it's ABC. I don't remember what the C abstract base class probably. I don't understand why this one doesn't have it though. Maybe this one inherits from the. Yeah, it doesn't. Whatever. So I'm probably gonna have to go over the batch thing, just what kind of arguments. Because besides these ones that are default, I understand the code. Maybe these ones are the ones, though. I'm gonna look at this function. But it's just a class that is gonna parse everything by using those actions things there. So it transforms the strings into Python objects and then uses the actions to determine what's gonna happen. So I need to understand how it's called, I think, or maybe I can figure out without doing that, but it's probably gonna be hard. So it would be better if I knew exactly what kind of arguments are passed by default, because that way I can understand what the grammar is gonna be. It's gonna be easier to understand what the grammar is. One back. And probably in Python, I'm not 100% sure, but I think that in Python is probably like the reason why you use the star operator for arguments and keyword arguments is because of the way the pointers work on C. So when you use the two pointers, you do the interaction twice. So whenever you have a list of pointers, you do this interaction twice to access the value. So, but I'm not really sure because it's probably a keyword arguments are probably a dictionary, but I'm not 100% sure. Maybe it is, because a dictionary is like it's kind of the same thing. It's just dictionary is just connecting to arrays with a hash function. So maybe it's just that. It's probably a pointer to a pointer, but I'm not 100% sure. This one is probably more likely to be that, but. So I assume that these are the functions that I was looking at before. And it's probably just gonna create the object and then calls the action there in the end. Yeah, dictionary from their arguments. So it's just adding to the list of actions at the beginning. And let me see. It just creates a dictionary, so creates a dictionary, then pass this stuff on the dictionary. And so here is specifying what kind of action it is. And then it's gonna get that action. So it gets the string, is this one. And on this registry. Also it's just registering here. So this one is gonna be this one. So each one is a class that is gonna determine what happens. So this pattern here, I think it is the inheritance or the abstract pattern. So you declare like the parent class is like a template, which is the action in this case, and then the other classes are just variations of the same template. And the abstract base class, I'm confusing abstract syntax tree with abstract base class. The names. So I think that this one is gonna be the class there, and then it calls, initializes the class with the arguments. So let me see again what kind of class it is. It's gonna be on the registers. So the action there is gonna be this one. So it passes the keyword arguments to this one, which is gonna initialize the parent. And so it's passing these are the keyword arguments, I think. But it's not the keywords, it's all of them because it uses the args on the other function that creates the keyword arguments. So I think it passes all of these arguments here to here. Initializes here. And then it just creates an action thing based on that. It doesn't look like this class has anything interesting though. So it loops over the arguments. It doesn't have anything. It's just converting everything to a Python object, I think. Based on the inheritance. So this is supposed to be the sub parser. It's gonna return there. I don't understand why. Like, it looks like it's supposed to create based on this, but it's not passing this as an argument there. So here it doesn't pass anything related to this name here, but this one it looks like it's passing this to create this thing. Oh, it's using this. And so it created before. I remember. Where did I see this? I think in the beginning there. I'm looking at the wrong one. Maybe this one. It has to be here. Yeah, so this one creates the thing, but also doesn't have any name. Or maybe this one creates the other one. Oh, here. Types of. So this is gonna be the parser class. So it's just gonna be this class here. So yeah, that this class is this one. So this, I think that this is composition. Just creating an instance of this class inside of this one. So it's using both inheritance, both abstract base class and composition, both inheritance and composition on this. So probably is this one, the function there. Generate C code. Yeah, it makes sense. I don't understand very well the nuances, but it's probably this function. the main function that is gonna parse everything, like the one that I was looking at the beginning. And this one here, it's probably passing the arguments, and this is gonna be this function here. Yeah, so I'm pretty confident because of the type here. Build C parser and generator. I want to see if I can do it on C++ though. So maybe translate, or maybe create a simpler version of this. I don't want to worry about, because obviously they have to do it like this so that it supports a bunch of different people using for different reasons. But because I'm only going to use what I'm thinking about building for like my specific use case, then I want to get rid of all this other stuff that doesn't matter. So like just get the function that actually creates the parse tree, and then from that do the other stuff. So I think that's probably, I try to do it on C++ because C++ seems to be better than C because that it has a bunch of other functionality. Obviously that's why they created, so it's probably better to try to do it with C++. And also because I'm going to use C++ on the other one to create the graph, so probably makes sense. So translate this from Python to C++. Once I figure out the main components, and then try to test, get the grammar file, try to create try to parse or create a code that is going to create the parse tree from the grammar, then create a graph and connect this project with the other one to use the barn set simulation. And once I'm able to do that, then I can think about probably gonna try to finish the book and all the other books first and become better with C++. But then after all of that, I need to understand more the back end of the compiler. Really understand the key thing that I'm trying to understand now is the data structures and algorithms distinction. What exactly is a data structure? And then I have a bunch of different ideas of stuff that I can do. File name, tokens file name. So this is the main thing, the main function, and it's just going to return this.
Isolation is the gift. All the others are a test of your endurance, of how much you really want to do it. And you'll do it, despite rejection and the worst odds.
And so this is the one. I should probably write this down. It's not that complicated actually. It doesn't look that complicated, maybe it is. Luckily I didn't have to, because now I'm pretty confident that this is the function. So I'm just gonna open the file, which is probably gonna be the meta grammar there. So it just opens and this file is gonna be this one. And then this code is gonna be the one that translates the strings of the grammar into the other function, into the functions that are gonna create the parse tree. I gotta organize this more as well because there's so much stuff. It's difficult to remember where did I put. I'm probably gonna put on the C++ file. So this is the other project that I want to look at. I'm probably gonna look at this one now. Maybe I spend some time because the issue is that I've been here for almost 2 hours. So, and I do want to look at this project here. This one I got it from GitHub, and it seems like it creates a simulation using barn set algorithm and in 3D. Here's what I'm looking for in C++. So I want to merge this one with the other one, get the grammar, create the code, then build the graph, and then use the other one to visualize. Python bag notes. I'm gonna write down
If you're going to try, go
what are the functions
otherwise, don't
that's most likely create the code for the parse tree. So I have to remember.
go all the way.
I have to remember how the this one. I think I'm gonna look at this one later, and I'm gonna look at the other project now. I'm probably gonna look at this one for half an hour, and then I'm gonna stop and continue to read the book Softstring. And it's gonna once it gets time to actually build this stuff on C++, it's gonna be annoying, and I'm gonna have to take a bunch of time to with the setup, because it's still one thing that I like, the way that I set up on like a example project to train in the beginning and to do the beginning of what I'm trying to do. I just follow a tutorial, and then the downside is that on the tutorial he uses the IDE of the Visual Studio Code to set up everything. So he uses this thing here, which is a CMake extension that allows you to just click on the stuff and build. But the issue of that is that it forces you to rely on VS Code, which I don't like. So I wanna become, or I wanna, yeah, become better and just like memorize how to set up everything with CMake directly on the command line. I think that's better. So I'm probably gonna struggle a little bit in the beginning to figure out to, uh, like, and it's especially very it's a lot harder because you have to think about the different architectures as well. So I'm probably just gonna focus on Windows, at least for now, because it's gonna be easier and it's the operational system that I'm using. So, but eventually it would be good to think about incorporating the if-else statements for the other architectures. But the problem is that it gets very confusing because on some compilers then the code works and then on the other ones it breaks. I think there are differences between them. So I have to, and I'm not really sure like which one to use to set up as the default for the project. Because obviously if you're gonna build from that one, then maybe later on if you want to change, it becomes annoying. So this is the project that does the thing. I'm probably gonna search on GitHub again to see. Then I'm just gonna go over the code here. The rest of the code for the other one I'm gonna look at once I finish the compiler book. I think that makes more sense because then I'm gonna have a better idea of how everything works, and then I look at the code, then I can start building. I'm gonna be right back. I'm gonna go for another half an hour, study the project, then I will stop. I'm gonna see if I can build the project first, then look at the code. I don't remember which repository. Maybe a clone or a fork. I don't remember really well. Trying to see if I can find on GitHub. Oh, I can look at the README file from the locally here. I should be live now. So it doesn't puts everything on the build. That's whatever. The problem is that yeah, I'm gonna have to delete the files. Maybe I should delete and put everything on the build folder. Because this one doesn't. So I assume that he is using Linux probably, and the default generator for Linux is probably make. So when you run cmake from Linux, it probably generates the make file. But if you're running from Windows, you have to pass the flag, the G flag. Because I think the default is using MS build probably. You pass the G and then Unix make files, I think. But I'm gonna let me see if there's other. Other instructions for Windows. I don't remember how I should run if I don't use the generator or the make generator. Like how should I run the program? Or how should I compile everything? Maybe just passing or calling cmake. I'm gonna try that first. Path to source. And the problem is that the cmake is the stuff that creates the stuff that is gonna compile. Let's see if I can ask ChatGPT. And this way, just maybe I should search for this later and just try to build with the generator, the Unix makefile generator. ChatGPT is saying to use Ninja, but it didn't use Ninja to build because there isn't any Ninja files. One thing that I have to see is how do I know which one is the default one? It's probably, maybe it is, I don't know though, like if it is like VS Code that sets the default one that is used on the settings, or if it's on the Windows sets the default one based on a environment variable or something like that. I installed CMake with Chocolatey, so maybe they determine which is gonna be the default generator that is used. I'm gonna try to just use the generator. I have to delete the cache. So the generator is Visual Studio. Let's see if ChatGPT. I don't know when was the last time that they updated ChatGPT for the data, but I'm pretty sure that now it has access to 2022, up to 2022, but I'm not really sure where the cutoff date is. And the plugins, obviously, is probably ways to connect with the internet. I'm just gonna delete and I'll search for this later. So this one includes all the directories. Include directories just the header files? Not really sure, but then it sets these flag variables, and it's pretty simple. The makefile just creates the executable based on all these CPP files. It's not that complicated actually. The more that I study CMake, It's just kind of confusing in the beginning to know exactly what you have to run here to integrate. So I'm gonna have to spend a bunch of time to get used, because the example project that I did on the other one based on the tutorial, he uses some variables there that I don't understand very well. But I believe that for to integrate other projects, external libraries, and use CMake to build them, you just have to put adds directory or something like that, or add include subfolder or something like that. Add subfolder. It's not that complicated. It's just annoying in the beginning. So I'm not gonna run this now because I don't know, like, if it's gonna fuck up the stream because of the space or whatever. Like, you can run with this to estimate how much time is gonna, how much disk space gonna take, but I don't wanna risk running on stream. I wanna run first off stream, so I'm just gonna look at the code. Then I'll look at this later. Let me read the README again. So it creates a simulation with stars using Barnsot. Barnsot is a graph algorithm. It's not sure if it is classified as a graph. Yeah, it has to be a graph algorithm, but it just creates the physics of stimulating particles and gravity and stuff like that. Just create the forces on particles. It doesn't have anything about the folder structure. This seems interesting. So I assume this is the, it's gonna be the main. Actually, I promise that this doesn't say much about a base main, so this is probably the entry point model. So the main thing is on the base, and the other stuff is on these folders. Obviously, like the name says, it's gonna calculate. So Barnsot uses a data structure called a quad tree to figure out the forces on the particles. So it pretty much divides the space on squares, and then based on the squares defines the distance, I think. And then based on whatever parameters it passes, it's gonna calculate the forces based on, like, it's gonna simulate the, like, gravity. But on 3 dimensions, you need an octree, so it's another data structure, which is just a cube. So the data structure depends on the amount of dimensions you have. And then it uses that to, it optimizes the process of figuring out the forces. It's faster than looping or going over all the nodes. Because on 3 dimensions, it becomes really slow, because you have to do a nest, like 3 loops, I think. And then if you use the octree, it's faster. That's why I like this algorithm. Okay, I'm just gonna go over the main files. Not really sure what integrator is as well. This is the same as using the 2 dots there. Just the references. or it performs indirection on the thing. You're just performing indirection twice. And if you don't put the arguments, then it just figures out the space. If you put more arguments than there is elements on the array, it's just gonna initialize everything to 0. Then if you put less, obviously it throws an error. Blah blah blah. It's just parsing the command line arguments. And what is stopwatch? Feels. These declarations can be very confusing. Like it's gonna take some time to get used to this. It's very different than the other languages. As you declare everything on the header file and then you define on the C++ file. So sometimes it's very confusing for me to understand. The biggest challenge I think is gonna be is both on data structures with pointers and with classes when it has inheritance and these types. That's when it becomes very confusing. So this one I've seen before is just for timing things. So it's very similar. Obviously it has to be because the fundamentals. So it's very similar from the using WebGL on the front end, because obviously WebGL is based on the Vulkan. It's based on OpenGL, which is a framework. Like it's a specification for being able to. It's kind of like an API that allows you to write the same code or roughly the same code for multiple different types of GPU. So it gives you vertex and fragment shaders to draw stuff on the screen, and vertex and fragment shaders. The vertex shaders are triangles, and the fragment ones allow you to put color on the triangles. So everything is drawn by the GPU using triangles. And OpenGL is a specification. I think that there are other ones. And then WebGL is based on OpenGL, but there's slight differences between them. But the paradigm, I think, is the same. You create a loop, and then you need the time to figure out. You need to track the time on the loop to figure out how much you're gonna move each time. So it's kind of like you're putting a bunch of frames together, like one after the other really fast inside of the loop, and then it looks like an animation. That's how it works. Imagine this is just creating the time for the loop that it's gonna create. And then it probably has functions or classes to create the objects, which is gonna be the circles and the edges. It's probably gonna be from the books that I've read so far. There are some books that talk about some functions from OpenGL is very similar from WebGL. But like when I did the stuff on the front end, I used 3JS, so all the classes were done for me. I didn't have to code the shaders directly. So I think that's the only difference that I'm gonna have to. Probably what I'm gonna do is just look at the 3JS code from the front end library that I have, and then see how do they. I remember going in depth, but yeah. Like I have to see what kind of functions from OpenGL to call to build the circle and the edges and the arrows. Yeah, so I'm not gonna look. Maybe I'll look into this one later. Unique pointer. Make unique. Yeah, this stuff is gonna take time. So this is, I believe that it is an example of a template. So just creating a custom type that is gonna be this one, which is probably declared on some other file. Let's see if I do this. Yeah. So just this class here. This public has these functions. And this is overloading. Actually, it's not that hard to understand overloading. It's harder to understand polymorphism and templates for me. But overloading is not that difficult. Like, it's just replacing the whatever logic it has on that it would originally or normally work with the operators. So whenever you're using these operators here in this class, it's gonna change what happens. It allows you to put your custom functionality on what happens when you use the operator on the class. It's very powerful, and Python has the same thing, but it's done their methods. Probably comes from C++, so it's just something that allows you to change the functionality of the normal operators. Interesting. Let's see if we can go show. So this is the definition of the function. I believe he uses OpenGL on this project. Maybe not. Maybe he created everything. Yeah, but it wouldn't make sense, I think. It has to be OpenGL to create the visualization. So it's probably this thing uses OpenGL, which is from the standard library. Maybe not. Let me see on the other classes if there's anything. It says creating a pointer, unique pointer from the file that you pass, or simulation directory probably. So you can specify, and there's probably a default if you don't specify. Also, it requires you to pass simulation directory. And this is the loop. So it looks like he is not creating like an animation, just it's gonna go over these amounts and then stop. Not sure if this is initializing the class or not. Yeah, I have to study more smart pointers. Very confusing. It wouldn't make sense. Yeah, this is a function from the standard library to create the unique pointer, so it doesn't make sense that this creates the class. So, but the question is, how does it? It has to be this thing here. Because like, how does it create the class if it's not passing any arguments? Then, like, what is the integrator and the force calculator? Because this is the constructor.
Isolation is the gift. All the others are a test of your endurance, of how much you really want to do it. And you'll do it, despite rejection and the worst odds. If you're going to try, go all the way.
And
Otherwise,
so this is the configurations.
if you're
Probably.
going to try, go all the way. This could mean losing girlfriends, wives, relatives, jobs, and maybe your mind. If you're going to try, go all the way.
So I think if you don't pass anything, then it uses this as the default. Oh, there was a note there that I remember. But I don't remember being this way that they demonstrate. But default arguments are the same as operator overloading polymorphism, I think, or something like that. Like, yeah, probably polymorphism. That you define the same function with different arguments, with different types. Let me look at the note again. I don't remember very well exactly what it means. 'Cause I think it was kind of vague on the book as well. But it's probably very similar. The logic is the same, it's just syntax sugar probably. Default arguments sometimes provide the shorthand form of function overloading. Yeah. That's the thing. Default arguments sometimes provide a short enough function overloading. Yeah, so it's probably syntax sugar. So maybe that's what's happening here. That these ones are the defaults, and if you initialize as a unique pointer, you don't need to pass. You just initialize as this class here without the timestamp. It's kind of weird that because it doesn't have this function advanced single stuff. It's probably because I don't understand the unique pointer very well, so I don't understand what's happening. But maybe just calling this function here from this class. It's probably just like this class and the other one that are being used on the inside of the function. Oh, is this one? So it is a virtual thing. So this one specifies, the other one implements probably, and it's passing. So this is the one that I wanna. Simple container. So this is probably the octree. The structure. Bounding box. Yeah, pretty sure that this is the structure. So this is the function that I'm gonna have to change, because I want to make it obviously based on the graph data structure, not the whatever he did here. There's also something that I don't remember very well, but I do remember reading in one of the books that they recommend. Sometimes they recommend you to put some properties of the, like whenever you have a struct that has positions, and I think the example was a rectangle or something like that, and you have properties, you should put the position inside of the struct, and should put the properties outside. And I think it has to do with something based on the private and public things. Yeah, but I don't remember very well exactly why. And also the this keyword is just a pointer to the struct itself. So you can have, and I believe, yeah, on the examples, I don't remember very well, but I think they do it with type def. Then I also don't remember if it is the same name that is usually used. Actually, let's change here. And then here you put star, and then here you can put or something like that. So I don't remember very well. Something like this. So whenever I have something like this creates a pointer to the same thing here. So it's like a pointer referencing the struct itself. And this is the same thing as using the this keyword. The this keyword comes from this stuff here, which allows you to access an instance of a class. I'm gonna stop here, and I'm going to continue to read the books off stream. I'm probably not gonna stream for a long time because I want to finish all these books here. But once I finish all these books, I'm gonna continue. I'm gonna study. I'm gonna continue probably on stream. I'm gonna continue to study this stuff. I'm gonna finish reading all the books off stream. Then once I finish all of them, I also have another course to do, so it might take a lot of time, because I want to finish them as fast as possible. Once I finish them, then I'm gonna study this one again, and I'm gonna try to merge this one with this one. So create with this project. So change the code, like just get the main part of the code here that gets the grammar, generates a graph, or that gets the grammar as an input, the grammar file, then generates the code that's gonna generate the parse tree. And then from that, so change this code so that not only generates the code, but it also generates the creation of the graph from of the parse tree. Then once I have that, then merge that into the other project that has the barn set, and then use that to create visualization from an input from Python code. So get Python code, transform that into a parse tree, and then visualize on this thing here. And I think that Python has methods to do that directly, if I remember correctly. But I want to do it from the code so that I have more flexibility, so I can generalize for other stuff. And I'm gonna try to clarify a lot more how the distinction between data structures and algorithms really work on the hardware, and spend more time focusing on the backend of the parsing to understand better how it works. So I'm not really sure when I'm gonna come back, but probably a few days from now. Either once I finish all the books, or once I go like a decent amount on all of them, and maybe have a couple. I think it's gonna take like probably more than like probably next week, until next week, because like each one of them is, these ones is like 8 or 10 hours. These ones should be around like 5, or this one's very short, like 60 or 70 minutes. These other ones are probably gonna take like combined 8 hours as well, so it's like a lot of stuff. Yeah, but till next time.